Okay, so here's another example of how we can solve exact differential equations, and we are asked now to solve this differential equation, but before we do that we need to prove that this differential equation is exact. So we need first to set this differential equation to its standard form, meaning that I'm going to have an equation that is m times dx then plus n times dy, and that's equals to 0. Okay, so let's move this part now to the other side. So we will have what? We will have x minus y cubed plus y squared times sine x. This is by dx, and then we will have negative, and then 3x y squared, then plus 2y cosine x dy, and this whole thing equals to 0. Now you can easily see that this is basically here. So this part of the equation is our m, and this part is our n. Okay, so let's now simplify this even more. I'm going to distribute this minus sign into the parentheses, so I will have again x minus y cubed plus y squared sine x. This is by dx, and this minus sign going to be distributed, so it's minus 3xy squared, then minus times plus, it's a minus 2y cosine x, then dy, then everything equals to 0. Okay, so now it's in the standard form, and now what we need to do to prove that if this is an exact or not, we need to find dm by dy, and we need to find dn by dx. If these two are the same, then the differential equation is exact. So let's first try to find dm by dy. Okay, so we actually agreed that this part here, let's change color, this is our n, right? Sorry, this is our m, and this basically the term that is associated with the dy is always going to be our n. So this is n and this is m. So let's differentiate m with respect to y. So I'm going to differentiate this part with respect to y. Derivative of x with respect to y is 0, and the derivative of minus y cubed with respect to y is simply minus 3y squared. Then plus, we have a product differentiation here between y squared and sine x. So the derivative of the first part, which is y squared, is basically 2y times the second part, which is sine x, and then plus the derivative of the second part, which is 0, times y squared. Well, this is 0, so we don't really need to write that. Okay, so that is dm by dy. Now let's try and find dn by dx, or dn over dx. So we're going to differentiate this with respect to x. So we have minus 3xy squared. This is with respect to x is going to be minus 3y squared. Okay, and then we have plus, sorry, we have minus, we have a minus here, and then we have again a product differentiation between 2y and cosine x. Now we're differentiating with respect to y to x, so y here is a constant and the derivative of a constant is 0, so this is going to be 2y times the derivative of the second part, which is cosine x. So the derivative of cosine x is basically minus sine x. Then minus times minus becomes plus, and we have now the same answer. So dm over dy equals dn over dx. So this differential equation is called to be exact. Okay, so let's now see how we can solve this differential equation. Now the first thing we need to do is we need to find df over dx, and we will set this equal to m, or we can find df over dy and set this to be equal to n. So you can start either way, but I like to start with this one. So I'm going to find df with respect to dx, and I'm going to set this equal to m. So let's try this. Df divided by dx equals m. Well, what is m? M is basically x minus y cubed plus y squared sine x. Okay, so now I'm going to multiply both sides by dx. Let's try this. These two will cancel, and now I will have df equals x minus y cubed plus y squared sine x times dx. Okay, so now after we do that, we can write df as f of x and y. It's a function of x and y, and to get rid of this dx we're going to integrate, so we will have the integral of x minus y cubed plus y squared sine x, and this whole thing is with respect to dx, so we're going to treat y as a constant here. So we will get the integral of x with respect to x is basically what? X squared divided by 2, then minus, we have y cubed. Y cubed is like any constant, so we will have the constant itself and then multiplied by x. Then we have a constant multiplied by sine x, so we will have the constant, and then the integral of sine x is minus cosine x. So this plus sign is going to be minus, and we have cosine x, and then plus c, and this c is going to be in terms of y. Okay, so now this, let's call this equation number 1. Let's call this equation number 1. Now the second thing you need to do is you need to deal with this term now. Now we started with this term, we found df over dx, we set that to be equal to m, and we found the general solution, and we said that it's our first equation, which is this one. Now what we're going to do is we need to deal with df over dy, and we're going to set this to be equal to n. So let's try this. Let's write df over dy, and we're going to set this to be equal to n. Okay, but now df over dy means what? Means you have to differentiate this expression, which is our general solution, with respect to dy. Okay, so let's try this. Let's differentiate the general solution with respect to y. What we will get is x squared divided by 2 with respect to y, that's 0. And then minus y cubed times x, that's minus 3xy squared. And then minus y squared times cosine x, the derivative is going to be 2y times cosine x. And then the derivative of c in terms of y is going to be c prime in terms of y, and we will have to set this to be equal to n. So let's rewrite this again. We will have what? Or we can have some space like this. Okay, so we need to have n in this side of the equation. But what is n? Let's try and find n. Well, there you go. This is our n, right? So my n is minus 3x y squared minus 2y cosine x. That's our n. So we will have to set this equation to be equal to n. So we will have in this side minus 3x y squared, and then minus 2y cosine x. Okay, so now you can see that you can easily cancel these two, and also you could cancel these two. So now you have c prime in terms of y equals 0. Now I have c prime in terms of y, but we actually need only c. So I'm going to integrate both sides with respect to y again. So what's the integral of c prime in terms of y? Well, that's a c of y. The integral of 0 is just a constant, let's call it k. Okay, so now we're going to plug this into our first equation, which is the general solution, which is this one. Okay, so Instead of c in terms of y, I'm going to write k, right? So this is the final answer is going to be what? X squared divided by 2 minus y cubed times x minus y squared cosine x, then plus c, well c is now k, and this equals to 0. And from that you can shift all of these guys to the other side, so we will get k equals minus x squared times divided by 2, and then plus y cubed times x, then plus y squared times cosine x. And that is your final answer.